Welcome to Uplink, where we explore the world of digital infrastructure, uncovering the technology fueling AI and cloud innovation with the leaders making it happen.
I'm your host, Michael Reid, and my guest today is Martin Bosshardt, CEO at Anapaya. Martin shares his journey from pioneering SD-WAN in the early 2000s to building SCION, a next-generation internet architecture. That's right. We explore how this technology is protecting critical infrastructure and redefining what's possible for the internet. Let's dive in.
All right, well, welcome to another session, another podcast for Uplink. And today I'm joined by the CEO of Anapaya, Martin Bosshardt. And it's a real pleasure to have you here on the show. Now, we're in Paris at the moment. You're based in Zurich. So thanks for popping in. And then I think you're off in a few minutes. You've got to get to London. So we'll try and smash this one through. We've got our big event on tonight. But before we kick off, I just wanted to just rewind, not about your current role, but actually just rewind back to 2000 when the world was caving in and tech was collapsing. You joined a company at that point in time as the co-founder and CEO. And from what we can tell, you invented SD-WAN back in the day. And so this is a really fascinating story that I'd just love to just unpack and then head into what you're doing right now with some of the cool stuff you're building.
Yeah, thank you. No, obviously that was a crazy time when the .com sort of industry collapsed, right?
Yeah.
It wasn't me that invented SD-WAN. It was a whole team, obviously. But we were running VPNs at that time. We call it just VPNs.
Yes, in 2001.
2001. So it was very, very, very early.
Jeez, and I'm trying to remember. Did we have VPN? Would I have even known what a VPN is then? I don't know.
Yeah. And then, industry started to use these networks to globalize their value chains. And it was a very, very successful, great time to build those.
And things. The company was Open Systems.
Open Systems, yeah.
And you ran that for
27, almost 20 years.
Yeah. So what were you doing back then? And then that was interesting because I was actually at Cisco when the Viptela acquisition occurred.
Right.
That was sort of the tail end of all the SD-WAN taking over from MPLS, and so this massive change with telcos globally. But you were there right at the start, sort of building that out.
Right, and obviously at the beginning it was not so clear whether you can really use internet for corporate traffic, and we were focusing on operation of that. So we bought all these products and stitched it together to a service, and then as you mentioned, Viptela, these were really products then coming into that market, giving companies also certain opportunity to operate that by themselves.
And the difference was from that business was probably more along the lines of something like a Cato Networks today, I suppose, versus a Viptela function. Is that how you would sort of...
Right. I think early, I guess. Cato, in a way, took basically what we did as a blueprint, I would say.
Okay.
But did it in a very, very exciting, large-scale way. But the idea of running an SD-WAN as a service, that's... And it makes a lot of sense because it's not so easy to run an SD-WAN, actually.
And so Open Systems, you ran for 20 years, I think got spun out or sold off into private equity?
Yeah, we sold it into private equity, and then they scaled it. We scaled it a lot, and,
awesome.
and it became a large SD-WAN operator with more than 180 countries.
And, wow.
We were learning a lot about how internet works great, and where the limits of internet is, and that also brought us then to the research community. And already in 2015, we learned about the SCION technology, which is basically an upgraded version of today's BGP protocol running the internet.
Let's unpack that. SCION, so SCION, Secure Internet Architecture.
Right.
Sort of came together, I think you were saying, was it a Princeton professor or something like that?
It started in Carnegie Mellon and Princeton. Professor Perig really kicked it off. I mean, it was mainly his research field to understand how can interdomain protocols become secure as closed networks. And that was then the whole idea of building a scalable route-based protocol. And that then came to Zurich, so he got a chair there, and the whole research became really big, I would say, in 2013, 14, 15.
If we look at it, the internet and maybe just touch on the protocol that runs the internet is BGP.
Right.
And BGP's been around, what, since?
No, it's from the 80s.
The 80s.
And I mean, it's bigger than the steam engine, if you think, right? I mean, it really changed our planet.
100%.
And I think,
we're still built on this. Like the entire internet operates off this platform.
BGP.
It's BGP.
And BGP is just, I think, one of the greatest invention of mankind.
Yeah.
It's just amazing.
It's undervalued. People are not aware how good BGP is.
Most people don't even know that there is BGP.
But basically, without BGP, there is no internet.
There is no internet. There is, I mean, basically,
Border Gateway Protocol.
Right. Border Gateway Protocol, that was the stroke of genius in mankind, right?
Yeah. I mean, it's underrated, and we're bringing it to the surface here on the Uplink podcast. Now, one of the challenges with BGP, and we see this a lot, you see a lot of BGP hacking, so like BGP routes that get sort of stolen or you publish a BGP route into the network, and so you can sort of take Google's internet. You can also get a lot of these DDoS sort of issues that occur. So I guess the SCION becomes this, I guess, a protocol in effect, or is it?
It's pretty much if you want an upgraded or a different version of BGP.
So BGP solving some of the security vulnerabilities, some of the challenges, but also giving you low latency, speed, a whole heap of things that you were
right. Your BGP connects every dot with every dot at all times, and that's the superpower of BGP.
The magic, yeah.
And at the same time, that superpower starts to become a super threat because we see a lot of IoT devices connected to the internet which are compromised. So you're facing more and more toxic players attacking you. And BGP is not really designed to fight that. So
BGP is just to get everything connected to everything. The challenge is...
And it's amazing how it scales.
Yes.
It's really powerful.
Yeah.
But at the same time, it starts to eat itself. I mean, attacks become more and more cheap. And defense becomes more and more expensive. So that's a very unfortunate trend.
Yes.
Now,
there's entire industries. I mean, look at Cloudflares and Fastly's and Akamai's. That just, they are protecting against DDoS attacks or BGP hacking, all these different pieces that they're trying to solve for.
And at the same time, it gets harder for them as well to protect because obviously the attacks also become more sophisticated.
Yeah.
The whole AI really helps now to really run very sophisticated attacks. Now, in the SCION world, you have full control over the route. So in BGP, you have no control where your data is traveling, and that's exactly the main attack vector you can run against those BGP networks. Now, in SCION, you can control where your data is traveling, and most important, you can use several routes at the same time. That makes it extremely resilient, very, very performant.
That's very different.
That's very different.
And that's kind of going back to that world you were trying to solve back in the SD-WAN era.
Exactly.
You could lag maybe one or two links, but then you'd have a minute failover or 7 minute, whatever it is.
Yeah, and you always had to decide what traffic do you shoot to the left leg and what you shoot to the right leg. It's not really load balancing in what you can do in SCION.
Yeah.
But if you bring it down to performance, science brings you all that performance capabilities you usually find in closed networks.
So you're leveraging the internet like a closed network.
Right.
You can't be seen so you can't attack it from a BGP, or at least the hackers can't see it.
That's then the other amazing attribute of SCION, that you decide who gets your routing information. So you can decide, I want to give the entire world my routing information. That's basically what we have in the internet, today's internet.
It's publishing,
But in an SD-WAN space, for example, it doesn't make sense that everybody knows the routing information of all those, right? So you only want to share your routing information. Let's say you have 100 participants. Those 100 participants want to share their routing information among them.
Okay.
But no one else should really be capable to route to that.
So you're building a private network across the internet, which you can extend beyond just your premises. You could include partners and so forth.
Exactly.
That's interesting.
Exactly.
You were saying before that you can get some insane speed or improvements in 1,000 was the number that I think you gave me before, which is a small number in terms of improving the speed.
Sure. No, there are tests where you can run through a megabit network, terabit traffic.
Wow.
Or a gigabit network, you can run terabit, because you can bundle routes.
Okay.
You know, in the BGP world, usually every connection has one route that's provided by BGP.
One
right?
point. It's from here, and there's your
exactly,
point.
and then you have one route.
And it can change, but only after a certain period of time, and so forth. Yes.
And in SCION, you can use 100 routes at the same time, so you can bundle those.
Okay.
And that obviously gives you new capabilities in terms of performance, but also, and that's almost more important, tremendous capabilities in terms of resiliency. So if you have a failover in the SCION world, this happens in milliseconds.
Which is, amazing. Nothing compares.
On the application layer, you don't feel failovers anymore. So all these capabilities really are, we believe, what the internet needs, because the internet obviously became the most relevant, most important network there is.
Yeah.
And it was never designed to be that. And now suddenly with SCION, the internet really can be absolutely perfect for critical infrastructure, like in the utility space, financial services space.
And you're in Zurich, so I think there's some pretty critical financial services that you're in the right space to solve this.
Yeah, right. I mean, it's great you're mentioning this. I mean, Zurich lives from the financial services sector, right? And obviously,
and secure and
right. Yeah. No. I think, and that's also, these are fair attributes that the industry was really building on. And the financial services sector, in particular, is more and more using and dependent on the internet. And that was also the reason why the Swiss National Bank decided in 2015 already to test this infrastructure for the financial service sector.
Okay, so 10 years ago.
Yeah.
So it's been around.
We always say, like, SCION is probably the best tested network technology there is. And I think for a reason, because it was meant to use existing internet infrastructure for hypercritical applications.
Yes.
Today we are running the interbank clearing system of the Swiss financial services sector on that new internet.
So it's not private links, they're actually using internet links that you turn into a private link in effect using SCION. And you still encrypt across the top as well.
Yes, because SCION runs on layer 3, so basically it is really a routing protocol.
Yes.
It is not an encryption stack. So, and once you have robust routing on the SCION internet, you still want to encrypt your content.
Yes, okay.
But then I really believe you use encryption for what it was meant to encrypt content and not to sort of
solve the route.
Solve the routing problem.
Solve the issue of the internet itself.
Yeah, exactly.
Yeah, okay. And so when you build out on your side, what are you building? You build routers actually. To solve for this. And where do they sit? What do they look like?
Anapaya is a software company, and we build an entire carrier-grade router suite to operate SCION technology.
Yes.
And
it's unique. I mean, if it's a protocol...
Yeah, the protocol is open source.
Yeah.
It's a published stack. There is a book. It's also, there is the SCION Association pushing the standard forward.
Yes.
But there was no commercial router producer so far, so we really started with that.
And it's a software router?
It's a software router.
So you can spin that up on compute stacks and awesome.
Any existing infrastructure.
MVE, which we'll talk about in a bit, where we're going to look at pushing that to all of our POPs globally as well. So
yeah, that's exactly. We were using a SCION basically in the Swiss market, proving it. Currently, we run 2.5 million transactions with a value of about, I think, 400 billion a day on that new internet. So it's really important. A day, right? There is a lot of money cleared between. I think there are about 300 banks clearing that, and then there is a healthcare network where about 30,000 doctors are using the network every day. So
amazing.
It is very well tested, robust in that ecosystem, and obviously now we are very, very happy to work with Megaport also to bring this technology on a global scale, because it's absolutely tested and ready to do that.
Yeah, you've tested it in probably one of the most secure places on the planet.
Yeah, you can't find it.
And now it's time. So you've proven it.
Yeah, because if you wanna use this technology for critical infrastructure, it's really important that you have the track record that it really works.
So you were chatting before we had a chance to catch up, but one of the good examples that you gave was utilities as a great example, where what's changing in the world, and if you look at even around this room, everything's getting connected. And so what you had before was this ability to control what was on your platform. Private networks, everything's privately connected, an MPLS backbone or whatever it used to be. And now all of a sudden what you've got is, okay, fine, we've got all these locations connected, but separate to that, every single solar panel, every single meter that's on a customer's premises is now connecting back. Each one of them is a vulnerability. Each one of them has a connection now across the internet. There's no way you can run a private connection to each one of those. So like the scale of this is like huge. Now on your side, you don't need to build at the edge. You're building centrally. And so you build these big fat monster routers, I guess, inside the ISPs or inside.
They are placed pretty much where the BGP routers are, where networks peer with each other.
Yes.
You place a SCION router. You can also segment your network and put a couple of more SCION core routers.
Yes.
But yeah, it really gives an alternative protocol that allows to create isolation domains for this critical stuff. And as you say, the grid, the power grid was absolutely isolated. Let's say maybe 10 years ago.
Of course, even air-gapped.
Right.
Yeah.
There was no way you could attack a grid. And now suddenly you have solar farms, you have heat pumps, or you have car charging stations, and everything is controlled through the app, right?
Yes.
So these loads and power producers, they are becoming a big threat for grid stability.
Yeah.
And it makes sense to bring those on a SCION internet where you have the same capabilities from a user perspective, but you can isolate those services from the rest of the internet.
But I think it was in Spain most recently. We've had some challenges with the grids.
Right, and I mean, obviously nobody knows if somebody knows more, but we talk to these people because we are running critical networks. And it really looks like it is very hard to understand what really happened.
Yes.
Because it could be that it was an attack. We believe not, but
it's hard to know. Yeah.
Fact is, these grids become more vulnerable, and it makes a lot of sense to not expose them to the internet.
Yeah. Okay. What are you guys looking to do? For you, is it world domination? Where you're at from a scale perspective? You've got billions of transactions, trillions of transactions over a year coming through the platform today.
Right.
That's looking to scale. Where's your head at?
Well, we believe, having the proof now that this technology works great for critical infrastructure in the Swiss market, that makes it absolutely capable to also give this technology to a larger region. And first, we believe Europe could profit a lot, and then obviously the US could profit a lot from this technology. But other regions, it introduces digital sovereignty for organizations, digital sovereignty for countries,
sovereign
for regions, sovereign.
Yeah, so you have an ability to keep. That's the other piece that we probably didn't discuss, is you can control the paths,
right,
and you can ensure that it doesn't leave, I guess,
jurisdictions, for example.
Yeah.
So
which you cannot do with BGP.
No.
It's not possible.
No, it was not designed to do that.
No.
So
yeah.
So I think it's really about having partners like Megaport who can use the technology to offer a much better network to the world.
Yeah.
And I believe. Yeah, BGP was bigger than the steam engine.
Yeah.
But let's say the combustion engine was also important. And
yes.
I would say SCION maybe is the combustion engine of networking.
Or is it the electric engine?
Yeah, exactly.
No.
So I don't believe BGP. I mean, BGP is great, and it will stay, and it's all cool.
Of course,
but for
yeah.
critical infrastructure, I think it's great if we can introduce this new technology on a global scale, and
Yes.
partners like Megaport can use this technology to
And it
provide
doesn't
that.
break BGP.
No.
Yeah.
No, it coexists
Yes.
perfectly
Yeah.
along. And that's also very important. A long time people were believing we have to improve BGP or we have to replace
to it or
BGP.
something. You can't.
That's not real.
Yeah,
That's
you
not
can't.
going to happen. But to have an alternative path, an alternative peering methodology to interconnect large networks, that makes perfect sense. And that's what SCION offers.
We've got 600 different banking and finance customers in Megaport, and I get the chance to sort of have conversations with the folks running these networks. Are pretty large banks in pretty senior positions, and some of the challenges they're getting from a security standpoint is quite astounding. And what I find interesting was, you mentioned it before, but the attacks are getting far more sophisticated.
Right.
They sort of run a wave of different vectors. So they're like very organized, and then they start hitting. And the second you change, they change. And so they're actually got a plan associated to it. We've seen them hit some pretty prominent banks, and the guys are responding. So they're like, punching different high-speed connections across to Cloudflare or moving something here. They're actually sort of responding. When you ask them, like, why? What's the purpose of the attack? That's the weird part. Like, they don't even fully know why they're under attack. It's not, in some instances, like if you get crypto locked, you know that they want some Bitcoin to give you your content back, and you're like, it's money, it's obvious. Some of these instances are proving that they can hack it. So they're just saying, like, let me, they're almost doing a resume. It's like a job, proving that they can hack something like a bank, then to get some work or something. It's a bizarre. It's so hard to actually pinpoint, like, what on earth.
What
is
exactly
happening.
they want? Well, and a lot of it is fully automated.
Yes.
We
Like as soon as it detects that something's been blocked, change to this path.
Right.
Engage all these other PCs. They've got hacked somewhere and start punching DDoS route, whatever. Like
Exactly.
It's wild.
It's a very professional industry. We've seen, for example, remote access for home worker. That became very, very prominent to attack, because obviously if you can compromise such a device, you're right in. You're in, right?
Yeah.
And these devices are usually attacked like. Obviously, we have scanning activities like 80,000 times a day or something.
Yeah.
That's pretty standard. And then we have maybe about 1,000 code injection attempts and fingerprinting attacks a day on such a device. The moment you have a vulnerability, a zero-day vulnerability, it takes minutes. And then they're ready, because there are already catalogs available who has installed what and with what releases. Those fingerprinting attacks run daily. That's more creating the catalog. Where can you enter the moment you have a vulnerability?
Interesting. So they're just cataloging where they can get to. They're not doing anything. And then
we had a 0-day on a specific device on the 10th of January last year. On the 15th of January last year, there were already 1,700 compromised enterprise organizations. So imagine in 5 days, that's very professional. I mean, it's not an easy job to do that, right?
Yeah.
So it's obvious that the attacking side also becomes very, very professional and dangerous. Yeah.
What do you think about, totally random, quantum and sort of where that gets to? I mean, we've heard these interesting stories around, countries just downloading data, encrypted data, and storing it.
Yeah.
And then at some point when they can crack it, using either some quantum or what have you, then they have the information. So,
that's happening.
Yeah.
It's astonishing to see how quantum really can open up those keys. It's not like faster. It's like instant.
Yeah.
So, but then obviously there are new encryption algorithms where you cannot open.
It's the counterintelligence, whatever it is.
Right.
Yeah.
Now SCION is using cryptography for signing the path. This is ready for quantum proof, but that's not. The moment a package travel the path, that information no longer is valid, no longer is of value. So that's why we are not really concerned on the quantum attacks at this point, because what really is happening that you can download content, encrypted content, and then wait and bring it to a facility where you have a quantum computer. But that's not an attack vector for a routing.
Yeah, it's different.
You would need to install a quantum computer on a router. That's not
because
very.
it's not storing the traffic, as in it's forwarding. Passing through the traffic. Yeah. Well, cool. Anything you wanted to share more broadly? Because I know I've got to get you out of here.
Yeah, right. I should have. That's the problem about networking. It's global. So if you have to travel to customers and partners, you're traveling global, right?
That's right. That's true. You're off to London. Yeah.
No, but it's really exciting, and we are very excited about this partnership with Megaport. We believe this can create a lot of value on a global scale, and it's great to talk to you, and also to see how you are bringing this industry forward and bringing innovation to the market. Very, very exciting. And I think if you look at what the world really changed, that the networks did change. Obviously, AI is changing the world now. And if we can make this planet a better place with technology, I think we should do it. And
it's cool. I mean, we've got something like 100. So we're in 930 POPs around the world, but we've got 100 physical compute stacks that we can deploy your platform instantly to 26 countries. So the scale that hopefully we can bring to you and to the platform is awesome, and the customers, you've already proven it. So I think the customer base is literally global. So super exciting. Appreciate you coming. We're to get you on that train. And very cool. You're building it again. Why you keep building these things? Are you bored or something?
We are who we are, right?
It's cool, man. I appreciate you coming in.
Hey, thank you so much. That was very exciting to talk to you. And then, let's keep pushing.
Touch, man. Yeah. All right, cool.